All right, today is lesson 2.6, solving absolute value inequalities. So you need to write these vocab in your journals. If you already wrote compound inequality and mean in your journal, you do not have to rewrite it. But if you did not, please do write that in your journals. I will give you just a moment to do that. All right, so solving absolute value inequalities. Remember, when you have an inequality, you have two answers, the positive version and the negative version. If you graph an inequality, you'll see, especially if it's, if it's equal to, you'll have the filled in circles. But the inequality x is less than, absolute value of x is less than 2 means that it's 2 away from 0, going both directions, going the negative version or the positive version. If it's x is greater, absolute value of x is greater than 2, that means it's 2 away, but then you see that it's going opposite of the 0.
So it's more than 2, except for one side it has negative.
Right. So then it's more than negative 2 or more than positive 2. That's a great way to say that. Does that make sense? Kinda? Mm-hmm. If x is less than 2 or less than negative 2, it's everything in between on this first one. And then your two answers over here, if x is greater than 2 or greater than negative 2, it's everything on the outside of the 2's. Okay? Comprende? You need to take a couple notes in your journal on this. You don't have to write the whole thing, but whatever helps it stick. So I'll give you just a moment to do that. All right, example 1. Write this in your journals. We're going to solve each inequality and then graph the solution on number lines. So the first one, the absolute value of x plus 7 is less than, I don't know why I paused it, less than or equal to 2. So you're going to write the two possible ways to solve it. X plus 7 is greater than or equal to negative 2, and x plus 7 is less than or equal to 2. All right, what's my first step?
Subtract 7.
On all of them. Yes. Now, one thing I want you to notice is which way the inequality faced when you put the negative there.
Wait, what?
So look at this first one. This is my inequality. X plus 7 is less than or equal to 2, but when I wrote it with the negative, I had to flip the sign.
Oh, because you're multiplying.
So pay attention to that.
That's difficult.
It's a memorize. When you deal with a negative, flip the sign. All right. So negative 2 minus 7 is?
Negative 5.
Negative 5, and 2 minus 7 is? Yeah, I was going to say this is negative 9. Goes further negative, and the other one was negative 5. All right, is x by itself?
Yes.
Yes. So you have solved it. Now let's graph it. So this is the one where you can put the x in the middle. See how x is greater than or equal to negative 9, but it's also less than or equal to negative 5. So that's the in-between.
What? So we have to write that. Okay.
Correct. So this is how you would write it. Negative 9 is less than or equal to x, which is less than or equal to negative 5.
Oh.
And then we can graph it. You can always write this inequality after you graph it because you'll notice it when you graph it. So I put on one circle on negative 9 and one circle on negative 5. They're closed circles because that's equal to. And then I shade everything above the negative 9 but below the negative 5. So once you see this graph, you'll recognize that you need to write the compound inequality like this.
Okay.
Does that make sense?
I get it.
Good. She says confidently. You'll be fine. Two biggest takeaways from here is make sure when you write the negative version of this inequality, you flip the sign. And then once you get to the answer, rewrite it as a compound inequality. All right, I'm going to guess this is probably the or up here, but we'll find out. All right. Must be, by definition, the absolute value of an expression must be greater than or equal to 0. So we know it cannot be less than 0.
So this is only 1.
So you don't actually have to solve this one.
Oh.
Wait,
what? No solution. Oh, I see.
Remember, we can't have a negative number on an
when it has the
absolute value.
Why
Well,
do they
it's
do
not
that?
less than or equal to, it's just less than, so we can't have a negative answer. So you would just say no solution. Now, if this had an equal to sign, we could solve it. Because it can equal 0. It just can't be less than 0.
Because we can't have negative.
Can't have a negative absolute value. That's the whole thing of absolute values. It makes it positive.
It probably is.
Probably with all their luck. All right, any questions? Okay, let's go do your monitoring progress. Numbers 1 through 3. Okay, so we're going to solve each of these inequalities. So A, this is example 2A. So write your two possible answers for C minus 1 is greater than or equal to 5. So you're going to have C minus 1 is less than or equal to negative 5, and then C minus 1 is greater than or equal to 5. Why did we flip the sign?
It's negative.
Because we made this number a negative.
Yeah. 4.
Okay, so then we're going to do what on this one? Add 1 over here. So negative 5 plus 1 would give you a negative 4. And then we're also adding 1 on this side, and we have 5 plus 1, which is
6.
Very good. So C is less than or equal to negative 4, or C is greater than or equal to 6. It says to graph it. So you're going to draw a number line.
How come it's 4?
Because it's on the outside. You'll recognize it when you graph. So we do a dot at negative 4 and a dot at positive 6. They're filled in because it's equal to. And then C is less than or equal to negative 4, so you just graph to the left. And C is greater than or equal to 6, so you graph to the right. So since it's everything on the outside of the two dots, that's why it's OR.
What?
So you should. Any questions on A? All right, let's do B. By definition, the absolute value of an expression must be greater than or equal to 0. The absolute value of 10 minus m will always be greater than 2, so all real numbers are solutions.
Wait.
So this is another example of one you don't have to solve, because every absolute value has to be greater than it has to be a positive number. So then all answers in here will turn out to be positive.
You just fill in the entire thing.
Thanks.
You just
leave it.
Say all real numbers.
all real numbers is all you have to say.
So how do we recognize that? Like,
So if there's a negative number and it's greater than or equal to or just greater than with that value,
Right.
it's always
Right, because the answer will always be greater than the negative 2, because your answer for an absolute value of something is always going to be positive.
okay, so every time it's the negative 2 is less than, then it'll be all real numbers.
This one, if it's
Okay.
if the absolute value side is greater than that negative number,
It'll be all real numbers.
then it's all real numbers. If it's the other way, where it's the absolute value side is less than, then it's no solution. Okay, let's do the third one. So right now you see that we have all kinds of stuff on the left-hand side that we need to rearrange so we isolate the absolute value expression. So what's the first thing we're going to do?
subtract one.
Negative
We're going to move the 1 by subtraction. Very good.
Shush.
So minus 1. 21 minus 1.
20.
Okay, now what's the second thing we need to move?
Divide by 4.
Yes, we need to move the 4 on the outside, so we're dividing both sides by 4. That just cancels the left side, which leaves it 2x minus 5. What's 20 divided by 4?
5.
Very good. Now, can we actually finish solving?
Yes.
Yes, so we write our two equations, or inequalities. So you have 2x minus 5, and then flip the sign, less than negative 5. Or 2x minus 5 is greater than 5. And our first step now is to move what?
The 5.
The 5 by doing what?
Add.
Addition. So we're going to plus 5 across the inequality. Negative 5 plus 5 would be?
0.
And then 5 plus 5 would be?
10.
So 2x is less than 0 and 2x is greater than 10 so far. Now what's the last step to get rid of by the x?
Divide by 2.
Divide everything by 2. 0 divided by 2 is?
0.
0. So it's just x is less than 0. 10 divided by 2
5.
is 5. So x is greater than 5.
So, but the second one won't work because the x is less than 2. No, because you're not in absolute value.
Right. So it's still fine. And then we graph it. So x is less than 0 or x is greater than 5. Draw a number line. Put an open circle at 0 and an open circle at 5. And it's everything to the left and everything to the right. Any questions? All right, let's do the next set of monitoring progress 4 through 6. Okay, so solving the inequality and then graphing. So what's the first thing you need to do?
I need to do plus 7.
Add 7. So add 7 over the other side, you get negative 1 plus 7.
6.
6. And then what do we do with the 3?
Divide by 3.
So 6 divided by 3.
Oh, that's what I did wrong. Okay, I get it now.
It's
I see what
2.
I did wrong too.
It's 2.
Okay, and then you'll write your two equations. D plus 1 is less than or equal to negative 2. And then D plus 1 is greater than or equal to 2. And then you just move the 1.
Hey, got it right.
All right, so how does this apply to real life problems? The absolute deviation of a number from x, that's what absolute value is talking about. Okay, it's the distance from x. That's what absolute value is. So you see here, the absolute deviation is x minus whatever the given value is. So we're going to do this example. Was this 3? Example 3?
Yeah.
Write it in your journals. Example 3, you're buying a new computer. The table shows the prices of computers in a store advertisement. You're willing to pay the mean price with an absolute deviation of at most $100. How many of the computer prices meet your condition? So what is the mean? What is that?
All of them added up and then divide by the amount.
What's another word for mean? Average. So yes, you would add all the prices up and divide by the number of computers you're looking at. Then it tells you you're willing to pay whatever the average price is, plus or minus $100. Does that make sense?
Yeah.
So, how many computers are there?
10.
10. So we're going to calculate the mean price by adding them up. So all 10 of those added up would be how much?
6,640.
And we're dividing by 10, and you get what?
664.
So the mean price of the 10 computers is $664. So now can I write a absolute value or a deviation from it? Yes. So x is going to be our variable. So x minus 664, put the absolute value, and what was the price he was willing to deviate? About $100. So it has to be less than or equal to $100. We understand how we created this inequality. And then solve it for x.
Do we do 2 different thingies or inequalities?
You can. You'll see here that they just wrote it all in one like we would a compound inequality. Guyona, you should be writing. All right, so if you have the negative 100 is less than or equal to x, minus 664 is less than or equal to 100. And then how do we get x by itself? We're going to add 664 to both sides. So the left side would be?
564.
And then the highest you would pay would be?
764.
So the range that this person is willing to pay for their computer is between $564 and $764.
Wow.
So at most, how many computers meet that condition?
6.
6 computers meet that condition.
So how do you write
So right now you have this equation as your answer. 564 is less than or equal to x less than or equal to 674. Says how many computers meet your condition. So you would tell me how many computers.
Okay, so
6 computers fall in. I would say 6 computers fall in that range.
do we have to graph it?
No.
Yay.
All right. So I think you just have one more monitoring progress. Yep, one more and you're done. All right, so everybody do number 7. It's probably very similar. Yep, look, you're even still buying a computer.
Oh, same number. Yeah, this dude needs to.
It's all the same except for the absolute deviation is what?
75.
All right, so you know how to set up that.
This person needs to learn how to